Mr. Ken Wheeler.
It's a lot more setup than usual. What's up, Atlanta? Hey. My name's Ken. I do some programming. I also make some beats. I'm actually a producer that does this code shit on the side, so not a big deal. It's temporary. And today, I'm going to teach you how to make 808s with JavaScript. And more importantly, math, because the shit is bananas. I'll get into it. So what is an 808? Now, if we have any purists in the room, an 808 is actually this, which is a what? Am I really doing this? It's just my face. It's this dude who looks kind of like a cop, kind of like Pitbull. Now we're talking business. Okay, let's try that again. Hi, I'm Ken. And I want to teach you how to make 808s and JavaScript and all that shit, but this is an 808. So technically that's an 808. And it's a classic drum machine, right? Full name is the TR-808 Rhythm Composer. This was introduced in 1980. And I think it only had a production run of like 3 years initially. Like it flopped, and then it turned out to be like the basis of every dope song ever. It was like $1,200 then. They're like $12,000 now. So it's kind of hard to get your hands on an actual one. Interesting thing, it was one of the first drum machines that let you actually program the pattern. Previously, like you'd be like, all right, do like samba, and it'd be like, this one you could actually step sequence it, which set the tone for a lot of the ways we make music now, digitally at least. And this is used on more hit records than any other drum machine, just iconic sound. And the way that it works is it's not actually drum samples, it uses synthesis to like imitate acoustic drums, but not really that much. Like it had a very signature sound. Like it was like, we're gonna make it sound kind of like drums. And I actually built one. This wasn't in JavaScript. This was in ReasonML and OCaml and OpenGL. It was native, and I'll show it to you so you could hear what I'm talking about. So this is what a regular 808 drum machine sounds like, basically. Well, maybe not. Am I still on the audio? Crestron, stop it. It sounds like Napoleon Dynamite or some shit. But it's actually crazy, the way that it synthesized some of this stuff. Like when I went to go, because I wanted it to be accurate, I went to go make the hi-hat, right? And it's actually like 8 different waveforms, like tuned a very special way. And it'll go, and you're like, what? But that's how it works. Back to the presentation. So, I'm here to talk about a different 808, not that. Now, these days, if you say 808, it usually means an 808 bass, a trap 808 bass. And I'd love to show you an example, but you know, if I play that, it'll get flagged by YouTube. If only I had some music that I own the copyright to. I do. Can we just acknowledge that producer tag for 1 second? Okay. So back to what is an 808 in this context. Like actually, at its core level, it's math.sine, right? It's a sine wave. This kind of blows my mind because back in the day, I'd be in high school and they put this calculator in front of me and I'd be in class, chilling. I'd be like, when the fuck am I gonna use this? Yeah. The narrator, he had to use this. Like, I was like, man, if my math teacher ever sees this, I'm sorry. So it's not actually just math.sine. Like if you actually want like a sine wave for music, it's the sine of your sample index in time divided by your frequency divided by pi times 2. That's here nor there. But what that creates is an oscillator. This is one of my favorite GIFs of all time. Also, this is a GIF room. If you do this GIF shit, you can get out. Fucking GIF. Right, so how does that, right? How does your TI-83, how does that get turned into bass? And this is actually mind-boggling. So the way that I'm going to do it today, or at least the way you've done it traditionally with JavaScript, is the Web Audio API. Can I see a show of hands who's heard of this or played with it? Okay, pretty familiar. So this is a built-in web library for dealing with audio on the web. Lets you play music, like if you wanted to play music on a website. Lets you synthesize sound, shit like that. And what's cool is it's like a graph, so you can like route things together in a signal chain. So you could like put on a filter, put on distortion, whatever. It's pretty cool. And you have also they have hooks into like the kind of raw data. So if you wanted to build visualizations with it, I'm sorry, my pants are falling down. Videos forever. So I'm going to show you a little web audio real quick. That's Ableton. That's not web audio. My shit was all maximized and nice, and now it's not. So let's look at what this entails, right? So I just put a button here, and we get that button, and then when you mouse down on it, if you don't have what's called an audio context, you create like the root level of playing audio in a browser, right? It's called an new audio context, right? And then from there, you can do all the connections and create all these different things. So here we create an oscillator, hilariously enough, a sine wave oscillator. And we assign it a frequency of 100. Now, a sine is just one of the different waves that you can do. Another one might be sawtooth. You know, if you're into like Skrillex and shit. But this is an 808 talk, so we're gonna keep it sine for a minute. So then you create a gain, right? And you connect the two together to the audio context destination, and then start it, and then you just call oscillator stop when you mouse up. And if you want to, it has, like the Web Audio API has other built-in stuff that's kind of cool. Like there's this thing called linear ramp to value at time. So it's a way for you to say, like, go to this frequency, like over time, animate, you're animating your ears. So if I say linear ramp to value at time, I go from 100 down to 40, and then you say current time plus 1, that's like over 1 second. Have you ever like seen like a movie, it's like an action movie, and like they're like fighting over like a Dodge Challenger or some shit, and then they approach a cliff, and they hit a rock, and the fucking shit goes upside down, and then it goes, right? So that's what that does. So I go to throw like a sick fucking roundhouse kick, slow motion and shit. But that's basic web audio, right? And that's cool, and that's the way I've done it for a while. I need a fucking belt on these joggers. God. But today we're gonna do it a little bit differently, right? Can I see a show of hands who's heard of an audio worklet? Heard of it? Heard of it? Audio worklets are the shit. So like with web audio, up until this time, right? Like you could do like kind of fun stuff like that, like make like stupid like action movie sounds and stuff. But like I would always be like, I can't build anything real. You just don't have the control. It's too much of an abstraction. Audio worklet changes that. it gives you direct access, and it does it performantly, right? So this lets you do audio processing off the main thread here. The way that it works is you define a worklet module, and then you register it, and then you can import it and add it, sort of like how I was doing you're still using web audio, but the same way I created an oscillator and added that. You can kind of import your custom thing and add that, hook it up to the chain. So this is what it looks like. You just extend audio worklet processor, constructor super, and then you have this process block, which I'll explain in a second, and then you just register it with a name down there, and that makes it eligible for use. Also, it is in a worker file, which is, if you're trying to make a demo and create React app, it's kind of a pain in the ass. You have to put it in like the public folder, but I digress. The way to actually use it is, right, you have it in your static path. And then somewhere where you're actually going to use the web audio API, like the same way I just was before, making cool action movie sounds. Like, you could do it with a then, but I do it with an await here. You say, see the audio context, audio worklet, add module. And then you do a path to that. And then you create the new audio worklet node, because now it's in scope. And you connect it to the destination. Or you could connect it to anything else. You know, it's kind of like a graph type setup. So that processing block is where the magic happens. You have inputs. So if you connect something to it, right, like it doesn't have to be like a synth, like your thing you could like write a distortion or something like that. So the audio signal that comes in, that's on your inputs. The buffer that you're going to fill in to send out, whether that's going to the destination or whether that's going to a different thing that you've connected it to, that's your output. And parameters are values on the audio node where you can change the frequency if you wanted to, or you can change the intensity of effect. That's how you control it. Also, I don't think they have like methods, right? So that's kind of helpful. Like if you wanted to trigger something the same way that you would with a method, you take a parameter and go from like 0 to 1 and back. And that's kind of how that works. And the basis of what's happening here is digital signal processing. Can I see a show of hands? Who knows about that? College must have been fun. Yeah, I didn't go, so this shit was tremendously difficult for me to understand. I heard DSP, and I'm like, oh, cool, you know, I'm gonna make like a reverb or something. And it turns out that it's super broadly applied to all kinds of things and not just making beats, like statistics, medical data, image processing, right? Like, you know, what we're doing here, like, it's kind of wild, like a low pass filter. Like apparently people use that to like find like fucking whales in the ocean or some shit. But like that's also what you use in like the part in the Drake song where it sounds like it's in a basement. Blows my mind. And the basis of it, right, is just an array of numbers. Like I've chilled a couple times before I actually got into this, like too deeply, and I was like, how does that like actually work? Like if you have like a CD, right, and like CD that comes to the speakers, like what's going on in the interim there? And it's arrays of numbers. So let's start with a thing called sample rate, talking about CDs, right? And this is the number of samples, right, or data points of audio per second, right? So it's like the resolution of your audio. So when you see like 44.1 kilohertz or whatever, that's 44,000 samples per second of audio data. When you look at this wave, right, like each line is a new sample there. So it's just numbers flying by incredibly rapidly, and that's how that works. And then you have waveforms. I showed before with the we have sine, and then we went to the sawtooth. There's a couple basic ones, like sine, like square. You like England rap, triangle, sawtooth. If you're into dubstep, that sort of thing. And what they do is they emit waveform values over time, these oscillators. And time is a big component in all the calculations for all of this. Frequency or your pitch, your note on the keyboard, that determines how fast the waveform is oscillating, right? So if you have something that's super high pitched, it's much tighter and faster. And then if you have something super low pitched, right, much more spread out. It gets so spread out, in fact, has anybody ever heard of an LFO? Not like that pop band, but yeah. An LFO, right? That was like the girls with yeah. I just outed myself on that one, didn't I? But yeah, like an LFO, that's how that works, right? Like an oscillator isn't just like it's just going to make like a bass sound. Like you can hook into these things, and the data that's returned from the travel of the waveform can be applied to like parameters, like doing a knob, and that's how dubstep works, right? You have an oscillator that's at a low enough frequency that the shit is going up and down, and then it's like hooked up to a knob, and it's like whoa, 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 and then yeah, you're instantly Skrillex. It's as simple as that. So time, right, determines where in this cycle of or the period, right, where you are, and that's called the phase, right? So if you look here, you see like a couple different phase offsets of a sine wave over time, right? It's where it lines up, and if you don't have them lined up properly when changing it, has anybody ever done like physics programming, like a game, and like you like fuck up the physics, and like your person walks and like fall, and it's like funny? Like it's the same kind of thing. Like it's like, so a period in this context is one full oscillation cycle. And for a sine wave, it's pretty straightforward, but some of the other waves, if you're gonna write the oscillator or generator, the period gets taken into account. It's called period time. So like something like the square wave, you say if we're below half period time, it's going to be 1, and if we're after half period time, it's going to be 0. And that's how you get like that jagged square deal. And it's like, so let's make a sine wave, because we're going to do 808s today, and that's sine wave. So here's a class to generate sine wave data. We start with a sample rate here, and that's a configurable value with the constructor. And then we have the current angle and the angle delta. So it's a little bit different than the equation that I showed before, but the reason that this is set up like this is if you change the pitch rapidly, and then you have it like this, and then it gets tighter, and they don't line up, it goes bananas. It doesn't work properly, right? It's like yeah. So you have to make sure that when you're modulating the pitch in real time, that all that shit lines up. And that's what we're doing over here. When you update the frequency, you calculate the cycles per sample. You set your angle delta here, and it has to maintain a counter over time. So here you say your current sample is the sine of the current angle, increment it, and then you return that number. Right? Now, using this, over there on that thing it says take a break. Is that like are you telling me? Or is that just like, I'm not taking a break, we're finishing this talk. Getting all sweaty up here and shit, pants are falling down. Actually using it is, you have a little private jam here, tone equals new sign, create a new instance of it. And then in our process block, right, we have our outputs. I'm not assuming anything's actually coming into this. It's just going to be an oscillator. It's just going to produce noise, not process it. So we're just worrying about the outputs here, and we loop over the outputs, loop over the channels, and then for each index that we can fill up, we call tone get data. And that will magically produce noise. As far as how loud that noise is, now that we have a tone, a regular tone, that's your volume and your gain. And this is where it starts to get wild, because like that stuff was pretty, for me at least, complex. But like volume and mixing, you're just adding stuff or multiplying stuff. So your gain here, right? You see how like a quieter one is shorter and the louder one is taller? So if you have these numbers that are flying by in arrays constantly, if you want to make them a little bit quiet, times 0.8. If you want to bump it up a little, times 1.2. It's absolutely wild. Whoop, whoop. So right here, right, I could say the gain is 0.5, and then right here, you just multiply it. And here's the crazier part. So I've been doing audio for a long time, and the lengths that I've gone to mix two audio signals together. Like I remember before I actually even had equipment, I had a turntable and I had 2 tape decks, and I would take 2 tapes and I would record the turntable to the one tape and then switch the tape into this tape and play this over the other channel, and then I would sit here and it would be like and I'd have this tone, I'd be like and it was terrible, and there was like all this like noise and shit on the finished thing was so filthy from like the tape sound. Like it was just it was awesome. But here in digital land, where everything is possible and you don't have to own cassette tapes, if you have 2 noises, right? 2 audio streams, 2 signals, 2 any of these things, right? The flute and a fucking bass or whatever. If you have 2 of those and you have the audio data for those 2 at the same time, do you know how you mix those? You literally add the numbers. Like I asked my boy when I was like first like building, and I'm like, yeah. So like, what if I want to add? What if I want to like multi-timbral? What if I want to do like a poly synth, right? Like, I want to have them both play at the same time. He's like, add them. I'm like, what? He's like, add the numbers. No. And I'm putting together, and I'm like, wow, math. Shit is crazy. Okay. Yeah, it actually worked, and it's crazy. So like, you know, now we have like we have our tone. Like, how do we shape that, right? It's not just a tone that just like, right? Like different things have different shapes. Like if you have a flute, like it starts up a little like, and then like you have like a bass and right? You shape it with an envelope. And what an envelope is we take that gain concept, right? Where you're gonna have a multiplier for your volume, right? And it's a shape of volume over time. So, there's a couple stages of this, and you have what's called the attack, right? And the attack is when it first starts up, right? So if you're listening to like house music and it's like it starts up kind of like there, like that's like a long attack. Whereas a short attack is just like, bah, like no problem. The decay is after the attack, after that initial like you're reaching peak volume, that's like your automatic drop off is the decay. Sustain is if you're holding the key and you continue to hold the key, that's like the volume the shit's gonna hold steady at. And then the second your finger comes off the key, that's your release. That's like your fade out. I was gonna do an envelope walkthrough, but I'll do that in a little bit. Like how that actually works is like a state machine kind of thing. I wanna talk a little bit about MIDI. And what MIDI is musical instrument digital interface. And it's a way of communicating values digitally. Like this thing right here is a MIDI controller. And without a computer, it's completely worthless. Or without, you know, a MIDI accepting. Wow, that shit doesn't even have actual MIDI ports on it, it's just USB. Yeah, without a computer, it's worthless. But, you know, it doesn't actually play any noise, it just tells the computer what notes you're pressing, or what control things you're pressing. Right, so we can send note messages, velocities, key down, control values, transport stop and start signals. It's a way of controlling these things. And it used to be like you could hang out and connect like multiple hardware devices together, but now it's like it goes into a computer. Not only does it go into the computer, it goes into the web, so we can build these things on the internet. So there's an API called Web MIDI. Essentially hooks up and lets you intercept data from this thing, select which one you want, all that. You could discover multiple MIDI devices. I plug it in at home, there's like 8. Here we only have 1. I like to use this library. It's just easy. Just npm install web MIDI. Yarn if you nasty. And you say web MIDI enable, right? And then it's in play, and you select which input you want. And then you can add an event listener here for note on and note off, and it'll give you which thing you pressed. So I wanted to talk about this. So I said I better build something. So I built, is this big enough to see? I could bump it up a little. Bam. So I built like a bass plugin in the browser. I've tried to do this sort of thing with the web audio API before, and it was slow, it was limited, but now that I have the granular access to the arrays of numbers, now I can do what I want here to craft the sound. So I built this. This is all canvas, you can see. Right? You can turn this down and you can get like a regular. I'm up here writing code. I love it. Yeah, and it's fun. Here's like your envelope that you can do in real time. Like you could do the attack, like right, long attack on it, short attack on it. You have the filter. So if we went up high or really high, it'll do a cutoff on it. It's pretty fun, and it works with an audio worklet that I wrote that we can run through. Is this big enough? Maybe too big. Whoop. Whoop. Right. So we have a, I call it the synth, and it's an audio worklet, and we track things like the pitch, different parameters about effects and everything like that. We have sample rate, frequency, gain, attack, decay, sustain, release, trigger, saturation, thump, crush. And these are all the parameters I was talking about before where we have this, like you have to be able to tweak different things. And that's how I can have that UI that'll change this in real time. I just want to go down to my actual generation. Yeah, so right here, just like we were showing before, I say we run through here, the outputs. We go and we do generate audio data. So if I hop back up to generate audio data, there's a lot going on here, but at the end of the day, we still are just doing the sine wave, which I can't, oh, it's, yeah, this.tone.update frequency, this.tone.get data. That's what gives me my sine wave. And then we add a couple other things to this to make it sound pretty cool. So first of all is that envelope that I was talking about before, and I'm gonna just scroll up. Right here. So to make that envelope work, right, we have the different stages of the envelope. We have off, attack, decay, sustain, release, and we have our multiplier, and that's what tells it like it's time to get louder or softer if you want it to be a certain shape. So I'll pop this out here, right, at different stages. We can come in. It's largely controlled by your note on and note off. As soon as you do a note on, it'll start going into the attack. And then when the time elapses for that stage, it'll go into the next stage. And it'll hang out at the sustain stage, this cool ass switch statement, until you let your finger off, at which point it'll go into the release. Right? And all this does is this gives you a number to multiply the signal by. That's somewhere from like 0 to 1, where it's going to stay normal or it's going to go completely off. And that's largely all there is to it. I'm not trying to edit this, I'm trying to go through it. So that's fun. We have this cool sonar sounding shit. Right? But it doesn't really knock. It's not that dope. So how can we make that shit knock, right? Like a lot of times, like people think 808 just a sine wave. So there's a couple steps to making this shit knock. So if you want the bass to have that, right? What you do is the same way that you do an envelope for a multiplier to, control the volume of it. You can do an envelope for the pitch, a multiplier that you can change the pitch of it, right? And I'll hop out and show you that real quick. I use that same envelope class in here. It's kind of hard one-handed here. Yeah, so here's my PM. So I take that thump parameter, because the label was a little long for pitch envelope modulation. So I called it thump. But right here, I do that and I get my multiplier. I've instantiated with, if you want to make a little kick in the beginning of this, what you do is you do a very quick envelope, like really, really quick, right in there, that just jacks the pitch up real high. And it'll give you like if you slowed it down, it would be like, pew, right? But it just, pew, if you just do it right there. Like the dude from Police Academy up here. so like here's without it. And then we bump up the thump. You hear it? It's a lot of fun. Oop. All over the place. So the next step, making that shit knock, is soft clip distortion. So like this, the signal is a little clean right now. If you do soft clip distortion, you jack the signal up and then kind of like round it out. That'll make it much fuller, and it'll make it filthy. Absolutely filthy. So here I have this apply distortion in here, right? We're taking the input, timesing it by 3, coming back in here and rounding it out with this soft clip. John. You'll be able to hear this. Oh, I'm done. I'm just gonna like drop this so I can control that and play this at the same time, so you can kind of like hear it on the up ramp of it getting progressively filthier. If you look at the oscilloscope right there, you can actually see what's happening to the wave. The oscilloscope is actually a pretty cool thing. I did that in Canvas, like filthy. And then if I turn it down, it's much. You can actually see some of the stuff I was talking about earlier too. Like if we go up higher, you see how tight it is? I was going to play Bob, but we don't really do that anymore. Yeah, it's wild. You can see it, like the signal start to square out, right? So the next thing is compression, right? And I don't actually let you do compression here. I do compression back here in my app where I'm building up the signal. Because remember that when you're creating one of these things, it's just one audio node in the web audio API. So when I call start audio, it's just one thing I'm connecting in. And that's where I do this low pass filter, and that's also where I do this compressor. Okay. Okay. All right, I'm about to wrap this shit up. So yeah, you have a compressor, which if you have like wild variation here, it'll kind of even everything out, make it sound the same. And then the last thing you'll do is bit crushing if you really want to. But I guess I have one last demo if I have to wrap it up. So what I did was I took web MIDI and hooked it up to a virtual MIDI output. So I'm able to actually control it through Ableton And that's running off of one of my MIDI tracks. So right here in software, I can route the control of this as well as the audio output if I want to record it. So I can actually make beats with this thing. Well, I can make beats with the thing if I actually hook the audio engine up to the headphone port. Wait, hold on, I just gotta do this properly for a second. Hold on, let me just, hold on.
Plug it up one more time, Kenneth.
All right, thanks so much, everybody.